Welcome, Heron and Riverside Scholars. If you are in Mr. Sutton's or Mrs. Parsons' Math 10 class, you have come to the right place. I know you haven't heard my voice before, some of you. This is Mrs. Parsons, and what we're going over today is Skill 23, the guided notes for that, and we're talking about bivariate numerical data. So we have some definitions that we need to get out of the way first. So what is bivariate data? Well, it's numerical data in two variables, and those two variables are x and y, which we're normally used to, that model real-life situations. Then we have scatter plots, which displays data corresponding to two variables at once to create a scatter plot from a data set with 2 points. We're going to plot each point individually on a coordinate plane. Sometimes when we're looking at this data, we'll see what we call clusters, which are data points on a scatter plot that appear to gather around a particular value. Okay, I joke around a lot that math people are not creative at all. We call it what it is. A cluster looks like a cluster of points. Then we have outliers, which are data points that are set apart. From most of the other values. So it'll be a lonely point way out in the middle of nowhere. So if we look at example 1, we want to label the cluster and the outlier in this scatter plot. So take a minute, take a second. Can you find the cluster? Your eyes should be drawn right here. Okay, this here is a cluster of points. Now, how about the outlier? You should have found this point way out here. Okay, he is set apart from everybody else. Okay, why do we get points like that? Sometimes we have anomalies in the data. Sometimes something didn't measure right. It could have been a mistake, but we still graph it and we consider it an outlier. Okay, Doreen surveyed 10 commuters about the distance in miles they traveled to work and the amount of time in minutes it takes for them to get to work. She summarized her data using ordered pairs where X represents the distance traveled and Y represents the commuting time. They're given these points, and we need to create a scatter plot to show the data and label each axis with the appropriate label. Okay, I'm going to pause here, and I'm going to go ahead and make that. All right, so you can see here where I set up my x-axis was distance to work in miles. Okay, where did I get that from? Well, it says x represents the distance traveled, and y represents the commuting time. So I had the commuting time here. I counted by 2s on my x-axis, and I counted by 5s on my y-axis. So I'm going to go ahead and plot each of these points. I'm going to pause the video while I do that, and you guys can go ahead and do it too. All right, so once I get all my points plotted, you should get something like this. Pretty simple so far. Okay, some more definitions that we need to know. A correlation is the relationship that exists between two sets of variables. So you can have two types of correlations. You could have a positive correlation, which means that the variables increase together, or we can have a negative correlation. And either of these, we could have a weak positive or a strong positive, a weak negative or a strong negative. And this will make more sense as we look at example 3. But a strong positive means they cluster closer together in a line, where weak means they're kind of more spread out. So let's look at example 3. We're going to describe the correlation represented in the graphs below as positive, negative. There could be no correlation at all, where they just kind of cluster in a random cloud of dots. And then we're going to identify whether it is weak or strong. So here in example 3, if I drew a line through this, what do you notice about the slope of that line? A lot of you guys should be saying, hey, it's positive. Yeah, so this is a positive correlation. Well, is it strong or is it weak? This one is strong. Okay, because they cluster very, very close to that line. Here, you see that the dots are also increasing together. So this is also positive. But why is this different? Both of them have a positive correlation, but this one is a little weaker than this correlation because the line or the dots are more spread out. Okay, how about this guy? Does it have a correlation? If we look and we think about it, I could draw a line either way, positive or negative. This kind of clusters in a cloud. So they don't increase together, they don't decrease together. So this one has no correlation. Okay, here we see that as this y decreases, the x's increase. So this is a negative correlation. Is it weak or strong? This is actually a weak negative correlation because they aren't all too close to the line. Here, on the other hand, we do have a negative correlation, but this one is actually quite strong because they all cluster very, very close to those lines. So based on the plotted data in example 2, what's the correlation between the distance traveled to work and the time it takes to get to work? Let's scroll back up. Do these data points have a positive correlation or a negative correlation, or do they even have a correlation? Well, you should notice that they are increasing together, so they have a positive correlation. Okay, this table shows the relationship between the prices of frozen yogurt and the number of cups of frozen yogurt sold that day. Give you all of your data points there. And we need to create a scatter plot, just like we did in the first one. So I'm going to go ahead and pause the video and make the scatter plots. Be right back. All right, so this is how I set up my scatter plot. On my x-axis, I put the price of the frozen yogurt, and I did it from 0 to 5 because that was in our chart. And I did cups sold, and I counted by 150, except right here. So that's how I set mine up. Let's look at the questions that it asks us. Describe the correlation shown on the graph, if any outliers or clusters. So let's start with the correlation here. Does it have a positive correlation, or is the price and the cups increasing together? Or as one is increasing, is one decreasing? Okay, This has a negative correlation. Okay, does it have any outliers? Okay, hopefully you're screaming, yes, of course it does. We got this dude way up here. Okay, why were 500 cups of frozen yogurt sold for $5? Who knows? Maybe it was a really hot day that day and people would have paid anything for the frozen yogurt. Maybe the frozen yogurt ice cream tasters came into town and paid the $5. We don't know. Okay, or we just don't know. Anything could have happened there. So yes, we do have an outlier. Holy moly, outlier at 5, 500. Okay, any clusters? You could argue that this is a cluster here. They're pretty close together. So we could say that there is a cluster around, say, 1.75, 275? Let's look and check that. 1.75, 275. Yeah, right around in there. What conclusion can you draw from the scatter plot? What's happening as the price increases? Well, we're not selling as many cups, right? Because people aren't going to want to pay $5 for a cup of frozen yogurt. So, or maybe you would. I don't know. Maybe you would. So, as the price increases, the number of cups sold decreases. All right, and that is it for skill 23. You guys have a good day.